Deciding where to submit, the legal profession is an example where you could write your dissertation and you could submit it to many different law reviews and shop it around. But in the scientific profession, in scientific writing, engineering, and all the hard sciences, you can only submit it to one place at a time. So it's very important for you to consider what journal you want to submit it to. One of the best places to start, of course, is to look at the reference. The main thing with your work is that you want it to be well read by your colleagues and other people in your field. So as you're looking at your references and you're compiling the material, it's often a good idea to look at that in terms of determining what are the type of journals that will consider your work. There are other questions to ask. Impact factor, of course, is an important one. It's important to building your career. But there are many things. The main thing is really to sort of build your reputation, get your work disseminated, and so having the proper readership is really, really an important thing to consider. Quick word about words. This is not a creative writing class. I always remember, when I was a graduate student, my professor would tell me that you need to write better than you talk. And so it's very important to be concise. If clarity can be achieved with N words, never use N+1. These editors will tell you as well that they're very busy people, so something that is succinct and concise and effective is really the way, as opposed to really trying to draw out a lot of descriptions that could get muddled somewhere. You really the article. Every journal has a little bit of a different structure, but I'm going to offer you tips or things that you need to know. It's important to pay very, very careful attention to the structure and the guidelines for authors. Many papers now, because there are so many papers that are getting turned in, will be turned down without a review. And one reason to give the editors to turn down the paper without a review is not formatting it correctly. So the introduction, methods, results, and discussion, MRAD, which we call, is the most traditional way to write a scientific paper. And if you see that in the guidelines, it's essential to follow it, to not get creative and try to put the results after the discussion or anything else like that. It's very important to stick with the guidelines and the structure as much as possible. One other tip I like to offer is also write backwards. So one thing that we typically do is we might start thinking about the entire article as a whole. Say, I'm going to start with the very first line of the introduction and write from point A to point B. But one thing that can help you is you have data and you're trying to tell a story to have people convinced that your data and your story is worth publishing, is really to write backwards. And what I mean by that is really start from the figures and the tables and not start with the title and the first line of the introduction. So if you start by writing backwards, seeing what you're trying to present, do the figures and tables followed by the methods and the results, and really the abstract and the title, especially the title, should be the absolute last thing you write. A lot of papers will fall into the trap, and this is not just with scientific writing, but coming up with a really catchy title and then writing the paper and it gets edited, and then what's in the paper no longer really matches the title. And so you're doing yourself some harm if you're writing the title first. This is the submission process, and it's a flow chart, and it's titled, it's not a black hole. When you submit, you often feel like you're sending something into a black hole. But basically, you submit the paper, and they look for the basic requirements. So that's that yellow diamond at the top, and that's a little bit of what I was saying. If it doesn't meet the basic requirements, if it asks for an introduction, then there isn't an introduction, or if it asks for a particular thing in the methods and that's not there, it'll go down and be rejected right away. If you do meet the requirements, then you go through the peer review process. The review process can take a lengthy time. All the reviewers, like the editors, are very busy people. We try to move that along as quickly as possible. The reviewers come in, and this is an important thing to remember, that the reviewers are essentially making a recommendation, and then the editor is going to make a decision. And the editor will basically either reject the paper, they'll accept it, or more likely, probably 90% or more, they're going to ask for revisions. So the revisions is basically sending it through this process again. It can seem like a very laborious thing because you're going through this, but this is the basic flow of how a paper moves through the peer review process. And the thing to remember is that it can go through a number of different cycles. so I've kind of gone very fast through things, and with the little time that I have left, I really want to spend what I think is the most important thing that you can learn in terms of trying to get your paper published. As I mentioned, most papers will come back requesting revisions. It's very important to carefully study the comments and prepare a detailed letter of response. And this slide, I want to spend a little bit of time with it. I've been in publishing more than 15 years, as was mentioned. I've actually hired a lot of people into the publishing profession. And one of the questions I always ask them is, what do you like and what don't you like about the peer review process? Most everybody always starts with what they don't like, and we'll talk about some of the things that they don't like. Very few people start with what they do like. And what is important about the peer review process is that as you're starting a career, especially as young scientists, young researchers, you're really getting very, very valuable feedback that will help not just with your paper, but your career. And so many ways I'd like to say that as you're starting, you should really cherish that chance to be able to discuss your paper, to discuss your work with the editors, to really digest what the reviewers are saying, because all of it is really done to strengthen your paper, strengthen your work. The second bullet point here is to cut and paste each comment by the reviewer. Now again, this is a very important tip. If a reviewer lists 7 points, has a bullet point for 7, or lists them number 1 to 7, it's important to break those out and answer each of those separately. One of the things that I mentioned is that there are so many manuscripts and people are just looking for a reason to reject them. And if you go through the review process and you come back and there's 7 points, but you only answer 3 and you don't address 4, or even if you address 6 but there's 1 that's still there, you're really leaving yourself vulnerable for people to say, this person didn't follow the directions, they didn't answer all of my points. Therefore, instead of sending it out for another revision, I'll just reject it. Very, very important to make sure that you answer the reviewer's comments or what's listed in your letter point by point. And you need to state specifically what some of the changes are. So you could answer the point, but if the reviewer, or the editor, does not see how that translates into the actual paper, then you're creating problems. So the best thing to do is really help out the editors and the reviewers as much as possible. If it's the introduction, you say, I've made this change based on the reviewer's comment, to specifically say, it's on line 8 of the introduction, and that'll help the editor and reviewer to go through things rather quickly, which is a benefit for you. You need to provide a scientific response. One of the things to remember, especially as a young researcher, is that the phrase that I mentioned, that the reviewers make recommendations and the editors make a decision. Now, the reviewers, one of the common complaints is that the reviewers really aren't that an expert in this field, and they're asking me to do something that's really not relevant. Well, you have the chance to really point that out to the editor. The reviewer is making a recommendation. I mean, some of the things I've seen over 15 years is that a reviewer is asking to suddenly start a big animal study when it's clearly not appropriate based on the work. You have the right in your cover letter and addressing the points to say, explain to the editor why that's not appropriate and give the reasons and really convince them that, despite the reviewer comment being there, that the paper should be published. Another thing that's often asked, as I mentioned, is that sometimes the reviewers and the editors will ask you to do more experiments. I think this, more than anything, really frustrates authors, thinking that their paper is essentially done and then they're asked to do something that might take them another 4 months or 6 months. And so the point I'd like to make about this is when you get that, really take a look at what you're claiming in the paper. As I've talked with editors and I've gone through publishing, a lot of times the editors and reviewers are saying they've essentially made a statement in this, in the discussion section or the results section, and there's nothing there to back it up. And I said, well, if they took that statement out and did not make that claim, would the paper be sufficient? And oftentimes the answer is yes. Not always, but oftentimes. So one of the things, the reason why people are asking you to do follow-up experiments is because you've actually written something, made a claim, but you don't have the experiment or the data to back it up. So as you're considering publishing, that's something to really consider when you start to see requests to do follow-up experiments. And then right in a way, where your response can be given to the reviewer. Again, that's if something happens on line 8, make sure you point it out. The reviewers are busy. As much as you can help the process along, that'll help you tremendously. Finally, the last piece of advice that I'd like to give you as young reviewers, or excuse me, young authors, is never resubmit your manuscript to another journal after you've been through the peer review and you've gotten comments back. And the reason is that the reviewer pool is very, very limited. The most important thing that you have going for you is your reputation. If you get 2 reviews back and they're asking for extensive revisions and you choose to ignore that and just submit to another journal and take your chances, there is a very good chance that the editor is going to send it back to the same reviewer. And when that reviewer sees that he had already reviewed it and you just ignored his comments and that you didn't do anything and you just thought you would submit it to another journal, that's a very quick way to damage your reputation. So take the process seriously, and when there's reviews coming in, even if you feel like you submitted it to a journal that's never going to publish it and you want to go to another journal, make sure that you take the reviewer's comments seriously and make some revisions based on that, because unknowingly that could really come back to bite you. So I mentioned this was like a 90-minute to 2-hour presentation. I think I've got it down in just a little over 10 minutes. But my email address is there, and if anyone wants the full deck of slides, I'm always happy to do that. Or if you have any other questions, never hesitate to send me an email. I'm always happy to try to pass on any advice or to answer any questions that I can. And with that, I'll turn it over to Josh.
Thanks, Bart. So I'll just tell you briefly a little bit about why I'm here. So I mean, sort of the unusual position of having stood on both sides of a fence in the sense that there are certain journals that have editors who do the editing as a full-time job. So I believe these gentlemen are journal editors who do this sort of on the side or in addition to their normal academic duties, and that's the case with lots of journals. But there's a set of journals, and this is certainly common in the biological sciences. I don't know to what extent it's true in engineering as well, where there are individuals who do this sort of full-time as their main gig. And I did this twice, actually, for 2 sort of short periods of about 6 months, just mostly as a fluke in that I was at stages in my career where I sort of had little bits of time to fill. And it was a great thing to do. I learned a lot from it. And I guess what I can maybe contribute here is talking a little bit about what those kinds of journals are like. And so specifically the types of journals that typically have full-time editors are what are normally called high-profile journals that sort of aspire to publish what they consider to be the most exciting papers in their particular area. So I worked at a journal called Nature Neuroscience, which is run by the Nature Publishing Group. Everyone here is heard of Nature, which is a weekly science journal that aspires to publish what they consider to be the most important papers of their time. And the Nature Publishing Group also runs a bunch of journals that come out once a month that typically specialize in particular subfields. Initially, those were mostly in the biological sciences, but they've now expanded. So I worked at Nature Neuroscience, and there's also Nature Genetics and Nature Immunology and all kinds of other ones that you can find out about. So there's a bunch of full-time editors that work at these journals, and one respect in which the publication process differs a little bit from the flowchart that Bart showed you is that at these journals, the editors play a little bit more of an active role in determining what happens to papers. And that it's not sort of the case that they simply they look for whether the paper meets their format requirements and then send it out for review. But typically the editors are making the call as to whether the paper should be sent out for review at all. And that's mainly due to the fact that the volume of papers that they get is actually pretty high. And so it's typically it's deemed to not be feasible to send everything into review. And so you have these people that are sort of gatekeepers to the review process. And at Nature Neuroscience, where I was working, at the time they were sending maybe 30% of the papers that they were getting out for review, and that percentage probably differs a little bit from journal to journal. So one of the very important things if you want to try to publish in these kinds of places is to write your papers in a way that makes the importance of whatever it is that you did relatively clear to somebody that's not necessarily an expert in what you do. Because the editors are usually not going to be experts in what it is that you do. In my case, all the editors have backgrounds in neuroscience, but you're reading papers from all over the spectrum of neuroscience. And so it's typically the case that you won't really know that particular area inside and out. And so to make the judgment call that you need to make, the onus is to a large extent on the authors to try to really communicate their results as clearly as possible. And so there's certainly an art to writing a paper in a way that will be effective for that process. One thing in particular that's very important is actually to write a good abstract. So typically at these journals, there'll be a person who's in charge of your paper, but the paper will be seen in some capacity by typically other members of the team. And as it's passed around, the other members of the team will, by and large, look at the title and the abstract, in my experience. And so it's really important actually to write an abstract that's kind of clear, that makes what you did clear, makes the contribution clear. And that can often be hard to do because you might say you only have like 150 words, but that's something that is really important, I think, to spend a lot of time on. So I think rather than sort of take more time sort of talking abstractly, it might be more productive for me to pass the mic to these gentlemen and then I can answer questions as a session.
Hi, I'm Albert Meyer, a professor of electrical engineering and computer science. I've been an editor of a little journal in theoretical computer science since sometime in the 1980s. I can't remember exactly when, but I know a few years ago they were trying to persuade me to hold a 25th anniversary celebration of my editorship, which I decided I didn't care about and we let slip. So I've been doing this for a long time. I think my top level observation really is that don't trust any organization. There are lots and lots of communities. Bart, I think, implicitly was talking about technical journals, and we probably agree with that. But, everything he said about social science journals inapplicable. Now, I'm not going to talk about social science journals either, but there are big journals, there are little journals, there are journals that are run by professional editors, there are journals like mine where it's a little journal. I run it by myself with one assistant who's sitting with me in the front row, Becky. And we've got about 30 or 40 members of the editorial board that I parcel things out to find referees. We publish maybe 100 papers a year. We probably get submitted 300. And more than half of them I summarily reject, just because I don't like them. They claim to have solved the people's NP problem. If you know what that is, how many people are with me on that? Okay. It's the major open problem in theoretical computer science. People write a 3-page paper claiming to solve people's NP. I write a letter back that says, we're not going to even send your paper for review, and if you're right, we'll look foolish. You'll be worth $1 million, and this rejection won't have any effect on your career at all. But we don't think you're right. So again, the top level message is that I'm really at an extreme. A little journal running an operation that is not exciting. We are an archival journal. Nobody publishes hot stuff in our journal. It's not what it's for. The hot stuff in theoretical computer science gets published in conference proceedings first, is vetted by the community. We have a very good idea of whether it's gotten an audience and whether it's important. And our job then is to get it certified by the academic community, go through the revision process. Quite typically, almost everything that we accept has been revised at least once in response to feedback. So let me just stop and ask you, how many people are in the field anything like mine? Anybody doing math or theoretical computer science? Anything like that? Control theory, yeah. The rest of you, how many people in biology, chemistry? Is that physics? Give me a hint. What else are you? Engineers of some kind? What's your field? Engineers, okay. And maybe the control theorist editor will be able to give you some feedback about engineering. But again, you need to understand the mores and expectations of your particular community, and they differ enormously from one journal to another, from one field to another. So that's maybe the top advice. What's expected of a professional paper that's publishable in your field? And it varies a lot. So another prejudice of mine is if it comes in Word, I won't reject it summarily because it's in Word, but boy, you're going uphill if it's not in LaTeX. Again, because that's the language of math and theoretical computer science. The only way to publish a decent paper is to use LaTeX. Just looking at my other points. Abstracts are, is nice when there's a good one, but they're not the central issue for us. References matter. If you publish a lot of old references and an inadequate number, that's a clear earmark for a paper that's not serious, not currently informed about what the research frontiers are, and I will often make the judgment that I don't want to waste my referee's time or my editor's time on a paper like that. I think that's probably enough comments, and I'll be happy to respond to questions.
Great, thank you. Yeah, those are all great comments. So my background is mostly, I guess, in engineering, but on the other hand, I started off as more of a theorem-proof kind of mathematics person, getting an engineering degree, and then over the years I've moved and published all over the place, including biomedical, physics, chemistry, electrical engineering, chemical engineering, mechanical engineering, aerospace engineering, so sort of all over. So I have experienced a wide variety of communities, and they are very different. The first comment I would say is some of the comments that was made in terms of the title, abstract, and conclusions. I would say from my experiences, from most communities, those are very, very important. When I was assistant professor, I wasn't so careful. So I'm a pretty good writer, but I would just write things down, and, it seemed reasonable. But the problem was I wasn't really thinking carefully about what I should really have that would optimize the impact of the work when I wrote titles and abstracts. I was trained really as a theorem-proof kind of person, so I didn't really realize that. And then over the years, many people have published very highly cited papers for stuff that I already published in my earlier papers, but didn't make it clear what the results were in the title and the abstract. So that's my own fault. And so I think that's very important. So now and then the conclusions, I would have some result I'd make as sort of an offhand comment to maybe the results section, but I wouldn't put it in the conclusions, and then somebody would write another series of papers, a whole bunch of citations for something that I had one of my papers with a comment. So I think over the years I've learned that that's a lot, it's quite important. Heavily influence the review process and who will read your paper and what the citations are. Now, the other thing is when you write a paper and selecting the journal, think very carefully about who the likely reviewer and readers will be. Now, one way of doing that is just see what gets published there, and then say, okay, is this paper or this results going to fit in there? Is it going to really fit into that kind of interest of that community? And is it written in the appropriate style for that community? If you take the work I do that's very theoretical, it's not just the results, but the style has a huge influence. Whether you come off as being really a knowledgeable person or come off as being kind of a hack. And so it can actually be, you have these esoteric kind of things that can happen depending on what the community is. If you write a manuscript that's great, but if you submit it for the wrong audience or write it for the wrong audience, it's going to be very poorly in the review process, unlikely to be read or cited, regardless how good the technical content fundamentally is. Now, there's another warning to watch out for, and it has to deal with experiments versus theory. So I'm not sure how many people do theory or modeling, but most of the high-impact journals are experimental, or they're controlled by experimentalists. What that means is it's much easier to publish mediocre new data with a very poor quality model than a great theoretical model with no data. Okay? So that second group is going to get screened out, right? Usually won't even be sent out for review. Okay, so at the high impact factor journals. And what it means is you'll get a high impact factor magazines and journals all the time, and you'll see models that are obviously wrong, just over and over and over again. And that's just the nature of that, because the review team can't really have enough theoretical experts. It's a small fraction of what they publish, and so it's really submitting that theoretical paper into an experimentally dominated journal. They just don't have the people to be able to really assess that and really evaluate it, and they don't really have the expertise. So that is sort of a weakness. There are strategies. One strategy, you send physical review letters if it's physics related. There are theoretical journals that do have reasonably high impact factor. Now, the second thing to watch out for is impact factor is in everything. So I have a colleague at Harvard who's an exceptional person, got into National Academy at a very, very young age, and he purposely does not submit to Science and Nature. He submits to biomaterials. And that's because everyone in biomaterials reads biomaterials. He submits it to biomaterials, it's going to get read, it's going to be cited. He sends it to Science and Nature, it may or may not be published, even if it is, he'll get less citations in biomaterials. So you really just getting into a game of just getting the highest impact factor is not always the best strategy. Now, another rule is don't get overly discouraged from your first rejection. In almost all the fields, it's pretty rare to just have a paper exception. Okay, so it's almost certainly going to be rejected or accepted subject to revision. The selection of reviewers is stochastic. In some theoretical fields like I work on, they might have 4 or 5 reviewers. But in some of the areas I work on, experimentals, we publish experimental papers, has 2 reviewers is common. So, well, if you have a small number of reviewers, it really influences stochasticity, whether you're getting into, happen to get the good reviewers, the reviewers that like your work, or the bad reviewers that don't. And so you have to take that stochasticity into account. In some fields, like in control theory, nearly the vast majority of the papers are rejected. So in other words, are not accepted subject to revision. So it's really can be very, very don't take that personal, and just understand the standard practice. In other fields, like in bio, it's very common to go to Science and Nature and then fail, go to the next one and fail, go to the next one. And sometimes groups will go this 4 or 5 times before they finally get to the appropriate journal. So, whereas in control theory, they won't do that because it takes a long time. The review process typically 5 to 10 times longer. So in that case, they'll typically won't try to sort of shoot up and then go down and go lower and just hit there and get it published. So you get quite a bit of differences in different cultures. Now, there were a lot of very, very good comments that were made. The only comment I would add, actually, to Bart's original comments is that some journals will allow you, so when you do your response, there's this gray area. So if you get, like, revision, and if it comes back, if it's relatively minor revision, the editor and associate editor can accept it without going out for review, okay? Or they can decide to send it all out to review and have the reviewers go through it. The difference in time is really quite different. If it has to go out to reviews, that's going to take a lot more time. So anything you can do to help that associate editor be able to accept your paper, you want to do, right? So it's going to make life make life better for you. So when we do the comments, even if the comment just puts bullets, put numbers. So write 1, 2, 3, so that all of their comments are numbered. Write your responses. Be very explicit about the change. But many journals will also allow you, when you submit the revised manuscript, to actually mark the revisions or highlight it in the article. And that really makes it easier, if the journal allows it, it really makes it easier for the editor associate editor. So then they can go through quickly, see what you did, make their own assessment if it's relatively minor revisions, and accept it sometimes within a few days, instead of sending it back to the reviewers. So it's a major time saver. That's all of my sort of semi-prepared comments. So I guess we can sort of open it up, I would suggest. So.